So hi, everyone. Thanks for coming to my talk. My name is Michael Beardo. I'm a data scientist at Energi. And today I'm going to talk to you about what Energi does, what are our use cases for Hortonworks data platform, and then I'm going to dive into our architecture and show you some examples of how we use specific tools. So the first thing I really need to explain is what I mean by a virtual power station, because that actually doesn't mean anything. So let me illustrate with a little chart what our current power stations actually look like. So the dark gray shows you all the installed capacity of these various fuel sources in the UK. And the light gray shows you how much of that we actually use. So as you can tell, the system is not massively efficient. I mean, if you sort of by analogy compare this to a data center, this would be like you asking your manager to build you a data center just so you can run Vagrant on your laptop. It's not hugely efficient, and it's been like that since Thomas Edison built the first generator that was only used about a quarter of the time. That is backwards, and we want to flip that on its head. And the reason, let me actually explain why it's like that. It's not because incompetent people built these systems. That's not the problem at all. The problem is that the people who built the systems are very risk averse for good reason. They don't want their lights going out. So they have to plan for a lot of additional capacity so that when you all finish watching EastEnders and pop your kettles on, Birmingham doesn't suddenly go off the grid. And I have it under good authority that Birmingham going off the grid is an emergency measure, by the way. So what we do is we do the reverse. Instead of asking a power station to turn up or down to balance too much demand on the grid, we connect to all these industrial assets like supermarket chillers, bitumen tanks, and water pumps that can afford to have their power consumption brought forward or deferred in some way. For instance, if you open the door to your fridge at home, your food's not instantly going to spoil. It's still going to be fine for a while as long as the temperature in the fridge doesn't go above a certain temperature. So this is the sort of thing that we do. And our customers include United Utilities and Sainsbury's, for instance. And why, from the point of view of National Grid, why would they want to do this when it's inherently a lot simpler to build a power station than it is to go out and convince people that what we do is valuable and to connect to thousands and thousands and thousands of assets? This is the reason right here. It's pure economics. What we do is something like 20 to 25 times cheaper per megawatt of balance than building a new generator. You sort of have this spectrum here. So the first sort of two options at the top are what are used at the moment, and the bottom two options is what we do and sort of what we would consider to be the future options. It's a lot more economical, and ultimately the goal is to reduce people's energy bills. So of course, it's not enough to have all this spare capacity and to be able to turn these assets on or off. You have to be able to do it quickly enough that it doesn't cause second-by-second imbalances in the system. In fact, we have very strict latency requirements, and that's part of our challenge. So just to take a typical example, so the chart at the top gives you an idea of what the balance is between supply and demand on the system in real time, and where it dips. So where it dips, right here, is where an interconnector tripped. So interconnectors let you transfer power between different countries. Interconnector happened to trip. And immediately, what happens? A lot of power has to be brought on to compensate for that interconnector tripping. Traditionally, what's done? There's a massive reservoir in Wales, and it'll just release all the water in the reservoir, and the hydroelectric power generated by that will compensate this. Of course, you can only do that for so long, so eventually a power station has to pick up the slack. If our solution was at a wider scale, we could compensate that just by turning off a bunch of industrial assets, and that is a lot more, as you can see here, that's a lot more cost effective. Not only is it more cost effective, but you don't have to build any additional infrastructure. There's no maintenance overhead for this. The assets are already there. And if you look at this purely from the point of view of power consumption, the line in the middle could show you at any given time what the power consumption is aggregated over our entire portfolio. At any given time, we can increase or decrease that power without having any negative impact on the industrial processes of our customers. And so we can flex it upwards more than downwards purely because most of these assets are off a lot of the time. So this is after all about data. So what does our data look like? So as I mentioned before, we have really strict latency requirements, and we also have very strict granularity requirements. We're often required to measure when we've delivered our service to 100 milliseconds or so. And we can't go around sampling the power consumption of every asset at the frequency of 10 hertz and storing all that data because, well, that would be impractical. And if your asset's off pretty much the whole day except for 5 minutes a day, you're just going to get a bunch of zeros in your data. And sure, there's ways to compress that data and make that more efficient, but it still doesn't seem like the best way to go forward. So the way we measure things is we sample it regularly. So whenever a value changes, that creates a new row in the database, basically. That's what our data looks like. It's a change of value series. And so you get something like these curves here, which are step changes. And then you have to ask something like, well, how much response did our portfolio provide over this frequency event? And how do you add these curves together? How do you resample them to get the mean power consumption of an asset in a given time period? And of course, there are algorithms to do this. I think we have a stored procedure in SQL. Well, we used to have a stored procedure in SQL Server and a user-defined function to do this, and it was absolutely ugly. It was maybe 5,000 lines or something to do this for all these different tables. And yeah, unfortunately, I wrote that, and I'm definitely not proud of it, but it worked, and as far as I know, it was the only way to do it. And it's inherent to this problem that you need very fine data, you have low latency requirements, and you need this aggregation to still happen quickly, and you need, at the same time, to be able to do batch analytics and simulations to help your customers be more efficient, because that's also part of what we do. So to give you an idea of how many messages of this kind we actually get, so at the moment we get something like 20 to 25,000 messages. So we've grown something like 300% in the last year. So it's a bit difficult to predict how many messages we'll have in the near future, but reasonably it should be within these ranges. Total size of data, 500 to 800 terabytes. That's really not huge. I mean, I'm sure all of you guys were in the keynotes. This is not exabytes of data, and I'm going to put this into perspective. Boeing, so they get the same amount of, or the same scale of messages per aircraft per second than we get for our overall portfolio. And their total size of their data is 100 petabytes. Now, the last time I spoke to a guy at Boeing, he said, yeah, but we actually don't analyze most of that because we can't. We just stick it somewhere, it gets archived, and after a while it gets deleted if no plane crashes, which they don't. So yeah, I mean, this is sort of the comparison. And of course, we actually do analysis on every single data point, and we sometimes have to do 10 or 15 different sort of flows that get kicked off by the ingestion of even a single data point. But it's still not, I would still not consider us at the point that I would say we have big data or even massive data. However, just around the corner is a very exciting event which is going to happen, which is that we won't just be connecting to massive industrial assets. We'll be targeting the tail end of the market, going to smaller and smaller assets, of which there are many more, and potentially even domestic assets like water storage, water heating. After that happens, our data is going to increase an order of magnitude pretty much overnight, and it's going to be a gold rush for all the companies that might want to do the same thing we do to participate. And whoever's last to that party is going to lose. It's not going to be us. So why did we end up going with Hortonworks? So obviously we want something that can scale quickly to respond to market demands. And by market demands, I don't just mean some hypothetical event about demand side going domestic, like I just said. I also mean real clients asking us to suddenly run an analysis of 3 or 4 years of data that we have on them to figure out if one tiny change to a control strategy could make a big difference to their power consumption. And this is routine occurrence. It's very hard to do in SQL Server when you're touching that many rows at a time, and when the DBA is the guy who sits across you. And so we can just turn around and angrily wave his fist. Interoperability with existing code was a big part of it. Most of our code is Python, and our workflow before Hortonworks was sort of get the data from SQL, do some analysis. If it's too much data to get in one go, iterate over a cursor or something. With Hortonworks Data Platform, or well, with Apache Hive anyway, you don't need to do that because you can cull into other code straight through. If you're familiar with the transform keyword, you can just call into external code through that, and you actually don't need to make any difference to your code. Your code doesn't even need to know where the data is coming from. Which is the next point about fantastic data integration, that you can query all these different data sources, which for us is things like national electricity statistics, national market data, that we can pull together to get an idea of where the market's heading at very small time frames, and which we can correlate with our own data to make decisions. Then there's obviously the knowledgeable technical support. If you're here, you probably already know about it, so I'm not going to talk about that. Security and data governance. We connect to assets that could be called critical for businesses. If either their data gets leaked or if our controller gets taken over by somebody, bad things could happen to that company. So we need to be very, very careful both about how we store that data and how we manage access to it. So this is something that's been at the front of our minds, and which was maybe one of the things stopping us doing this sooner, is that none of these Hadoop ecosystem platforms were enterprise ready. And I think Hortonworks are the first ones that have really taken this to heart. And so that was part of it for us. So, well, what does it actually look like at the moment? So everything we have goes in through Flume at the moment. I know somebody is going to ask about data flow at some point, so I'm going to say yes, we're playing around with it, but it's not in the system just yet. So I've been asked this a few times before, believe me. So we have things like asset data, market data, lots of other live time series data, which I guess you could just consider abstract streams. So they go into Hive streaming, which basically we have partitions in Hive, but you can't add data to a partition, so Hive streaming lets you manage that. And then we have all these different ways of analyzing them. We found that ways of accessing data that are interactive give you the best levels of adoptions within your team, because they can just get a result straight away. So for instance, Zeppelin lets you run Spark very interactively. Jupyter lets you do the same thing. And we absolutely love that, because you can just quickly show a commercial guy a chart in a few, well, maybe not a few seconds, it depends how big your cluster is, I guess. In a few minutes, you can show them a chart, whereas maybe you'd have to run a Hive query, copy and paste the data into Excel, and then make a chart and send that off to somebody. So it's absolutely brilliant. And then there's applications as well. So we use external tables that have plugins for Elasticsearch to index this data there, and that can then be used to power web dashboards and similar approaches. So that's the batch layer. The real-time, which is still ongoing work, is part of an exciting project we've got to use machine learning to infer the behavior of assets so that we can connect to the tail end of the market, where we can't necessarily have the same level of integration we do, where we send an engineer out to a site and they talk to some process guys on the site. They work out some hard-coded business rules over when the asset's available and power consumption and so on. So in order to do that, we need to be able to ingest all this data, and then every time the data gets ingested, we need to be able to determine, does that actually change the availability of that asset? Does it have more or less energy flexibility to give us at this time? So every time this point comes in, we have to rescore a machine learning model, and we also have to store that data, because that's one of our compliance requirements. So this is, at the moment, we're using Storm. Again, this might be something that we look to NiFi and Dataflow for in the future. And we can also correlate events, do things like that, put the data back into HDFS for when we need to query it later. And again, cache and Elasticsearch. I've mentioned Elasticsearch a few times. I know Solar is probably the preferred option. We were familiar with Elasticsearch first, so we've kept on using it. If you have small time series data, Elasticsearch is absolutely brilliant. It's aware of temporal data. It lets you do nested aggregations. And it has a really nice API to work with. So it's definitely something I'd consider if you have very small time series data, or if you have summary data to present. So yeah, I know presenting code in a talk is probably not the best idea, but I want to just give you a quick example of how Hive helped us in one particular task. So back in the day, this was first an SSIS job, which resampled data, followed by a Python script, which would then query the resampled data, join it with national electricity data, and then put that data into some file, which was tail by logstash, which then put the data into Elasticsearch. Probably better ways of doing that. So this is how we now do it. This is how we now do it in Hive. So the first thing is that we have an external table, which Hive knows about, and it can directly stick data in. So we can do something like select into this table directly from Hive, and it goes right into Elasticsearch, and that updates a web dashboard straight away. Now, the interesting thing as well is that all this complex analytics that used to live in a Python script that had to be scheduled, that can also live in the Hive query, and that's the thing at the bottom. So you can just select transform, and then all your machine learning or all your complex analytics you can take out of SQL. You can use whatever you're used to, SciPy or whatnot, get a result, and then that result is then available in Hive, and you can transform it further, or you can store it somewhere. And if you think about what that's doing, at the level of data integration, you've now taken potentially an arbitrarily large number of data sources, large number of rows, maybe you've pre-processed it in some way. You've then analyzed that data in Python. You've then gone and stored that in Elasticsearch, and that in maybe 10 or 12 lines of SQL plus whatever your Python code or some of the Python code was in the first place. And sure, you could do this in Pig as well. I mean, you're not limited to Hive for this at all. There's plenty of different approaches. But if you're familiar with SQL already, this is definitely an easy win. And as far as some of the data processes we had going on, this sort of thing really cleaned up the data processing we did. So of course, when we talk about benefits, maybe I mentioned that before we were using SQL Server. And as the data grows, and as we needed to do more and more simulations on historical data, we needed to go to more and more expensive SAN storage. Now we don't have to do that. It's about 5 times cheaper per gigabyte. There's also better utilization of infrastructure. Before we had sort of a couple VMs that were dedicated to just ETL tasks and just data cleansing exercises in general. They weren't utilized all the time, so there would be spikes of activity when they would come on, when certain data would be updated. Well, now that doesn't have to happen thanks to this containerization and Yarn, especially Yarn queues. They can coexist with other processes. They can coexist with Spark, with analytics. They can coexist with web queries. And all this can be segregated, not necessarily in the same way you would segregate multiple tenants in a data center, but they can be split into different queues so that you can very precisely control the resources that each thing is using. And we've found that to be very beneficial in how we control utilization of our resources. And ultimately, while we now do have more virtual machines than before, that's purely because we're doing more with our data. That's not because we're using it less efficiently. The other points I've already mentioned, I'm going to say again that being able to reuse your existing code is a massive advantage when you've been doing something one way for 5 or 6 years, and suddenly you move to a different data platform. If you have to tell your entire team, please rewrite all your code for this new data platform, they're not going to be very happy. But if you can say, just add this one line and everything will work, they might like you a bit more. And that's, well, maybe it wasn't just one line, but that's essentially what we found we could do, still deriving all the other benefits. So this is all the things that we would like to do with data, or that we do with data. And this is how Hortonworks fit in at the moment. So when it comes to prediction and forecasting, we use Hive and Spark. Event correlation, we use Storm. Aggregations, things like that. Everything that's real time goes through Storm. Again, Storm and Dataflow might be interchangeable in the future. Simulations via Hive and Spark. And that's roughly how it is at the moment. Thank you for listening, and I've left quite a bit of time for questions because I realize that these things are a bit broad, and probably people have more questions on what we do than I could explain in a few slides.
Well, thank you for your presentation. This was the nice weather view of it. You showed us the benefits. Can you share also with us some elements which are, sorry about the words, but pain in the ass?
Oh, yeah. Yeah.
What were the real challenges that you have encountered so far?
Oh, boy.
Or only one of them,
yeah.
The worst.
Okay, so the worst was probably initially getting the cluster deployed, actually. So we'd been using the sandbox up until then, and suddenly we decided, okay, we're ready, we're going to take the next step. So we had a look online, and there was this new thing called Cloudbreak. And we said, that's brilliant. We're just going to deploy this in a few clicks, and we'll have a working Hadoop cluster. We did do a few clicks, and we did not have a working Hadoop cluster. We had something that keeled over, and where the hard drives filled up very quickly because there was a bug in there at the time, which got fixed. And then a little bit later, there was another bigger or deeper issue, I would say, which was that the disks on the cloud provider we're using were not fast enough. And when you combine this with the extra layer of abstraction of Docker containers that were used by Cloudbreak, you were running into issues. That's all been fixed, thankfully. But you asked for a pain in the ass, and that was certainly a pain in the ass. Yep.
Have you considered using HBase at some point? Or if not, why?
Yeah, so we definitely considered using HBase. So we started off using OpenTSDB, which uses HBase under the hood. Yeah, it's a fair question. I mean, we really, at the moment, we're at the stage where we're just dumping data into HDFS, and Flume is a very convenient way of doing that. HBase is very good for time series data. It's very good for data where you can have windowing semantics as well. So it's definitely something we'll be looking into in the future. We haven't gotten to it yet, but that's absolutely something we'll look into.
You said that the Hadoop cluster is like 5 times cheaper than the SQL Server infrastructure, I suppose. Well, I guess it's the comparison. But what about the people on top who are operating it? Did you retrain your SQL Server stuff, or did you hire new people?
Okay, so the question is about the cost of the infrastructure versus the cost of the people. So yeah, let me first say the cost of the infrastructure. When I mentioned the storage cost, that's purely the storage cost. The infrastructure cost is probably about the same. But then, of course, you can remove SQL Server licenses and Windows Data Center licenses and things like that. So yes, about the people, actually, we haven't hired anyone new yet. I played around with Hadoop and Hortonworks and things like that in my spare time before I started in my current role. And then the other guys in my team had also sort of had this hacker mind frame, and they played around with it. So we actually found that we were able to pick it up as we went along. And sometimes we had some questions, and Hortonworks would answer those questions. But most of the time, no. I mean, we haven't had to hire anybody new yet. We are in the process of hiring one new person, but that's not specifically linked to this project.
So how many people are you in your team? I mean, given the industry you're in, I would assume you have 24/7 availability and support times needed.
Yeah. So this is the analytics system. So the core system, which is sort of data ingestion and real-time reporting right away to National Grid. That actually doesn't really have 24/7. No, I mean it works, but it can tolerate periods of downtime in the sense that if any one of the nodes fails, you have redundancy, and also even if all of our analytics systems were to fail, our entire service is completely distributed and autonomous, and we will still continue to provide the service. So the algorithms that we have that operate on site, all they need to read is this thing called the system frequency. So you can, if you plug into any plug socket in the UK, you can read it. So the algorithm's fully distributed, and even if this part were to fail, our service would still continue. And whenever this came back up, we would then be able to catch up with the missed events. So to answer the question of how big our team is, at the moment there's 3 of us, and there will soon be 4. Yes.
Just regarding the Elasticsearch, because it's not really part of the Hadoop ecosystem, could you tell something about the integration there and how much data you store actually in Elasticsearch and how much you have?
Yeah. So probably, in fact, so the question is how do you integrate Elasticsearch into HDP, seeing as it's not one of the included components. So I think you can probably do the same in Solar, actually, which I think is included. But OK, so we have an Elasticsearch cluster running separately. So this is completely separate from HDP, separate from Yarn. So it's not a large amount of data. I think that's probably the key. So this is data that's been resampled to daily resolution. So it's something like a few 100,000 documents, maybe. So it's not an enormous amount of data, and we have a 3-node cluster doing that. So the integrations themselves. So within Hive, like I said, you can use external table, and there's a third-party sort of jar that you have to include there. That was fairly straightforward. And for the rest of it, I mean, I don't know if you've worked with Solar before, but the sort of the API is just, you know, HTTP REST API, and it's got client libraries for pretty much every language, so it's quite easy there as well.
How often do you have to patch your system?
So at the moment, we actually don't patch that often. We just did an Ambari update last week, actually, which introduced a little bit of downtime. So I think, so we get, I would say maybe once every month, something like that. We probably would do it more often if we had somebody dedicated to actually administrating the cluster, which we don't. But at the moment, we probably patch about once a month.
Sorry, how long have you got it in production, and when did you actually start initial development?
Okay, yeah, so the question is how long have we had this in production and when did we start? So I think the first sort of proof of concept we did was about a year ago. And that wasn't this whole thing, that was just part of it. So the streaming part of this isn't in production, that's still sort of at ongoing work toy stage. So the batch, so that's been 4 months, give or take.
So 8 months to take it to development to production.
That does kind of seem to be the way these things go. You know, you start, you do a prototype in the sandbox at a very small scale, and you think that's automatically going to scale, but there's always little pitfalls and configuration things to work through. So yeah, it has taken us a while. Yes?
Yeah, I saw you were using external tables there. So are you just using a floating schema? Because when I tried that, basically it was unreliable. You know, all the tables would produce the same aggregations even with different data.
Sorry, I didn't get that.
So so you seem to be using external tables, so you don't have to rewrite it, or bring the data into structured tables in Hive. Basically, I've tried that and it didn't work.
Mm-hmm.
The floating schema didn't work. You had to structure the data. So that's one question. I'm just wondering how you got that working. And secondly, you were talking about the interoperability between Hive and Zeppelin. You were saying, oh, we can just query the Hive data with Zeppelin. Are they actually the same data objects that you're using, or are you making copies and then accessing them through Scala? Because I'm not sure how you access a Hive table through Scala, as it were. You know what I mean? So, and then if you're scaling, if every time you do a different query in Zeppelin, if you have to make another copy of that data, then you can introduce a lot of redundancy that way.
Oh, okay, let me try and remember both questions. So the first question was about external tables and how we got those working.
Well, do they work?
Yeah, well, they do work, yeah. So the Elasticsearch external table, that's the only external table we use at the moment. So that did take a bit of massaging the configuration because some jars actually for some reason weren't included. I think the Hadoop common jar or something like that was missing. So yeah, I actually don't remember all the steps we took because that was partly my colleague as well. But yeah, I mean, if you want, just email me and I can tell you more about that. Yeah, there was also an issue that had to be fixed with the jar of the people who made that external provider, because there was a bug on their end as well that wouldn't work with this flavor of Hadoop. So the second question was about accessing Hive with Zeppelin. No, we actually don't access Hive data with Zeppelin. We access Spark. So that Zeppelin is to access Spark.
Sorry, yeah. Well, I mean, can you look straight at the Hive tables, writing Spark code in the Zeppelin interface, or you have to make separate copies of that data, sort of reuse it again?
Yeah, I think that's worked. Actually, my colleague is actually the one who does all the Spark stuff. So I think, yeah, but I think it does create a copy, but that seems to work for us anyway, yeah.
No, it's not a problem. It's just when you're scaling, I mean, like you were talking, the way you made it in your presentation is that it's just one data set, and you can do it in Hive or Zeppelin, but actually I don't think that's quite right. You have to create multiple copies for the different ways you want to access it, and that can introduce a lot of redundancy.
Sure. So I guess Spark isn't really meant for handling enormous amounts of data anyway. Or I mean, it can do, but unless you want to have huge clusters, it's probably best not to do that. It's probably best to get your data down to, I would say, a gigabyte or less. So yeah, the data that we access through Spark is usually slightly transformed, and usually we'll use Hive to transform that data before we get it into Zeppelin. So we're never going to hit the entire data set, or all these data sets at once with Zeppelin, because that would require far too many nodes, and we just don't want to commit to clusters that large at the moment. But I mean, it is possible, though. Yes?
Just to mention about the frequency of sort of changes and capturing those, and you said that you're retraining your models every time. For longer time periods, then do you have a more longer standing model to capture sort of months or years worth of data, or how do you handle sort of the models for the longer term periods?
Yeah, so the question is on how we retrain our models, whether we have different sort of time windows. Yeah, so maybe I got that wrong the first time. We don't retrain our models every time we get a new event. We just rescore. So for instance, if there's a tree, you'll just get the next score for the model. So yes, that we have to do for every single event. At the moment, we actually don't have any long range models. It's quite simple just with simple statistical techniques like linear regressions or things like that to get the information we need. If we were going to go down that route, though, I think what we would do is we would transform the data first. So we have a lot of resampling processes as it is, so we would probably operate on the resampled data. And then we would schedule that. I'm not sure we would do it in such a streaming way if we had sort of longer range models, because then the additional data latency would be acceptable. And it wouldn't make sense to introduce the complexity of doing a streaming process for those, because there is additional complexity, of course.
More what I was thinking is you kind of sort of handle data sort of the nightly trough, daily peak. So there's a certain amount of times when it would be a good idea to have load on at night in order to bring the load up, so that you don't have to ramp up as much in the morning then. So there's advantages.
Sure. I mean, this sort of decision, I mean, that's usually something that we, because you're talking about changing maybe the way an asset operates on a site to optimize its energy consumption. That's something which we do in partnership with our clients, of course. But that's usually based on a batch simulation where we'll say, if you did this, then you would save this much money, or you would make this much money. And then the logic has to be changed at the edge layer. Because we need our algorithm to be very robust to communication failures. So if this was all living centrally and the communication link goes down, then maybe that really clever optimization you just mentioned would disappear. So that's why we can't actually have that bit living centrally. We have to do the simulation centrally, do the machine learning centrally, and then make the change to the algorithm at the edge layer. Yep. Yep.
With HBase in Hive, is that correct?
So no, the retraining. So what happens is that we have store MultiLine, and then the store MultiLine is what calls the scikit-learn.
We in Storm, but where do you train the model? Because I guess the Storm is only evaluating.
Sure. I mean, you just get but so the scoring just requires one point of data. So for instance, given the latest power consumption of an asset and the time of the day and the temperature, something, what is...
But you showed this Hive that uses Python script.
Yeah, that's not the machine learning bit. So that's when we need to transform data.
Okay.
So yeah, let me go back.
I generally would like to understand the whole architecture where to train the model, and I thought that you're using Python scripts for training.
We use Python scripts for training as well, but that's not done in Hive. That's a separate process. That's done through Storm because it needs lower data latency. If we did it in Hive, then we would need to schedule. Sorry? For retraining? No, not for retraining, no. So at Spark, we use sort of as an interactive querying and visualization tool.
Did you consider to rewrite those? Because I guess it's not trained in distributed fashion.
I think at the scale of the data that we're at now, we haven't had any trouble using Spark MultiLine with Python for this. It's very, I mean, the models we have are not, it doesn't take very long to do like a feed forward pass or something. It's very quick, so at the scale we're at, that will work. In the future, I expect we probably will have to rewrite them to make better use of Storm, and in particular not to call that bit out to Python, yes.
What did it take to use Python along with Storm and Hive?
Sorry?
What did it take in terms of how did you set up the cluster to use Python script?
Yeah, so that was actually a bit of a challenge because if you want, we use Python 3.5, whereas all these what's bundled in the cluster as it is Python 2.7. So not only do you need to create an additional Python installation, but you need to bundle all the right NumPy, SciPy, and all that stuff. So yeah, that was a bit challenging. But now that we've got it working, I'm actually very happy that we've done it, because it means we haven't had to change the machine learning code that we had previously.
So basically installed on every node of the machine.
Yes.
Python libraries.
Yeah. There's no way around it, unfortunately.
You talked about cloud and the clusters. Are you running on-premise or in some kind of cloud, or what? And what is the?
So the data. So this end here, that's coming from on-premise, and from here onwards is in the cloud. So the bit on the left is either on-premise or in a private cloud, and then the bit on the right is in a public cloud, so Azure. Yes.
A very quick question. I didn't quite get who are your customers? Are they energy distributors or producers or end users?
Yep. So our customer is the national grid.
Oh, okay.
So they're tasked basically with keeping the grid balance between supply and demand on a second-by-second basis.
Okay.
Yep.
What's the kind of throughput latency on your real-time decisions or scoring that you're producing?
Okay, so the question was around the real-time latency of the scoring and the decisions. So
latency and the volume that you're processing, the volume of
and the volume.
requests that you're getting, and what's the response time?
Okay, so the volume of requests that we're getting can be anywhere between 20 and 25,000 messages per second. Each of these messages could be something like power consumption or a change in a process variable, which implies that there might be a change in the underlying energy flexibility of that asset. So then we need to predict what the energy flexibility of the asset will be. And this is where the machine learning scoring comes in. So contractually, that has to be done within 30 seconds. But in practice, it's done much faster. It's usually done within about 4 or 5.
Why you don't use Spark Stream instead of Storm?
Yeah, actually we did. The question is why we don't use Spark streaming instead of Storm. We did consider using it at the time. Our Hortonworks reps told us that it was slightly less mature. So we went with Storm. But yeah, actually I've been looking into it recently, and it does have some promise. Having been to one of the talks earlier on Calcite and its potential for doing SQL on both data streams and sort of your normal static data, that might also be something that we look at in the future, or data flow. Yep.
You mentioned Zeppelin and Jupyter.
Yep.
Did you compare them, and which one did you choose and why?
So we went with Jupyter because we were familiar with IPython already. And Jupyter is just an upgrade of IPython. So as I understand, so I actually didn't use Zeppelin for very long, but as I understand, you can have kernels in multiple languages as well with IPython, which was quite interesting for us because some of our guys also like to experiment in Haskell. They wanted to try doing some data analysis in Haskell, which you can have a Haskell kernel in Jupyter. Maybe you can do that in Zeppelin as well, but we were familiar with IPython already. Right, I think that's actually all the time I have. So thanks a lot. Thank you very much.